Okay, so today we're going to be focusing in on section 9.1, which is all about midpoint and distance formulas. Now, midpoint and distance formulas, you actually will have seen them many times over the years. They get talked about in geometry, they get talked about in algebra, a little bit in advanced algebra, I believe a little bit in middle school. They're really easy. Midpoint formula. Finding the middle point of 2 points says that the midpoint, which still has to be a point, so there's parentheses involved, is x1 plus x2 over 2, comma, because it's a coordinate point, y1 plus y2 all over 2. Essentially, when you are given 2 coordinate points, which remember coordinate points go x, y, you're just averaging the x's and averaging the y's, and that's the middle point. Distance formula. Distance formula is just a modified Pythagorean theorem. It works with coordinate points on a grid. You can always graph it and draw a right triangle and do your Pythagorean theorem, but distance formula saves the graphing, says distance equals the square root. There we go. Of y2 minus y1, close that squared, plus x2 minus x1, close that squared. Essentially, the distance between the y's squared plus the distance between the x's squared will be equal to the hypotenuse squared, so you square root it all. Again, this is in the situation where you're given those coordinate points, but I'm not going to write that out again. Okay, so you're going to see some questions that say, find the distance and the midpoint between the following points. And it'll give you some coordinate points. So when it comes to doing distance and midpoint formula, like I said, it's not challenging. The biggest thing that messes with people is just paying attention to how positives and negatives affect the problem. It doesn't matter which point you call the first point, which one you call the second point. Just be consistent that you go xy, xy. And point 1 and point 2, if it's x1, it's y1. If it's x2, it's y2, etc. So, now with the midpoint, the formula says add the x's, divide by 2. Then add the y's, divide by 2. Negative 1 plus 6 divided by 2, comma, it is a coordinate point. 2 plus 1 divided by 2. Close the parentheses, it's a coordinate point. Those parentheses do not go away. And we simplify. In FST, generally speaking, we like simplified fractions. Negative 1 plus 6 is 5 over 2, which doesn't simplify. 2 plus 1 is 3 over 2, which doesn't simplify. So that's our midpoint. If those simplified, if I had like 6 over 2, well, 6 over 2 is 3. I would put 3. Distance. Now, distance formula people tend to make the bigger mistakes on, so I'm going to rewrite the actual formula here just so we have it handy. So, distance equals square root of y2, we said was 1, minus y1 is 2, squared. It's a plus in here. It's a minus in between, in the parentheses. It's a plus between the parentheses. x2 was 6 minus x1 was -1. Yes, it is minus a negative. Yes, minus a negative turns into a plus. So you want to write a plus there? You can. For the notes, I tend not to because the most common error that I see with distance formula is people add the x's and add the y's. You don't want to add them. You don't want their sum. You want the difference between them, the distance between the x's, the distance between the y's. To find distances between x's and distances between y's, you subtract them. Okay, this is -1 squared plus this is 7 squared, except this is not correct because these were in parentheses. And the negative has to stay in parentheses if you want to get an accurate answer. The 7 technically doesn't, but it doesn't hurt to have them because you need the parentheses around it before you square it. Otherwise, if I had written it without the parentheses, -1 squared is -1, but -1 in parentheses squared is a +1 because the first one says 1 times 1, then make it negative. This one says have a -1 times a -1. So be careful of that. This is not what we want. This is what we want. You should always have positives after you square it. If you don't, you put it into your calculator wrong if you used your calculator. That's 1. And 7 squared is 49. Add them together. We get 50. And this is FST, so we simplify. 50 divides by the perfect square 25. It's 25 times 2. Therefore, it's 5 square roots of 2. That's our distance. This was our midpoint. Like I said, nothing particularly scary. Let's do one more and then we'll be done. 2, 5. And 2, -18. Midpoint. Add the x's. Divide by 2, because you're averaging them. Add the y's. Divide by 2, because you're averaging them. 2 plus 2 is 4. 5 plus -18 is -13. I simplify what I can. 4 divided by 2 is 2. -13 halves does not simplify. And this should make sense if you're thinking about it as averaging the points. If you're averaging the x's and averaging the y's. The average between 2 and 2 is 2. The average between 5 and -18 is -6.5 or -13 halves. Distance formula. Big square root. I'm going to call this point 1, so it's x1, y1. Why did I write it 2? This one's x2, y2. You don't have to label them, but I find that it stops people from making mistakes. Formula says y2 minus y1, -18 minus 5. Close that squared, plus x2 minus x1, 2 minus 2 squared. Okay, be careful with your adding and subtracting. -18 minus 5 is -23. 2 minus 2 is 0. -23 squared is 529. 0 squared, 0. Add them together, I get 529. 529 is a perfect square. How do I know that? Because I squared 23 to get it. It's 23. In fact, on this one, I probably didn't have to use the distance formula to find the distance between the coordinate points. When the coordinate points share either an x value or a y value, the distance between those coordinate points is just the distance between the thing that's not the same. The distance between the number 5 and the number -18 is 23. Remember, distances are always positive. And if you're going to use the distance formula, when you square things, you get positives. But yeah, that's as in-depth as we are going for 9.1. It's just distance and midpoint. Your homework is on page 596. It is numbers 24 through 40, the evens.